So students, now this is the last part for the session for today, and I will be explaining more details about the binder jetting process. So the binder jetting process, like these are some of the advantages which are mentioned here. So binder jetting process, they allow the color printing as well. So you can print parts with the different colors. You can say that when you're printing them, it can work with a lot of different classes of materials such as metals, polymers, ceramic materials. You have seen already that in some cases you were printing the sand together to make the molds or cores that can be used later on for the foundry related applications for casting process. Then the process is generally faster than the others similar methods, and can be further quickened by increasing the number of print head holes. So if you increase the print head, for example, the type of nozzles, the number of nozzles present there, you can you can increase, or you can make the speed faster as well. The two material approach allows for the large number of different binder powder combination, because you are working with two different materials in the system. You have the powder particles which are basically available in the powder bed, and you are using different binders. So as a result of this thing, what would happen? You have a lot of combinations where you can work with different type of powders, and you can work with different type of binders. As a result of this thing, what would happen? You can get a different type of mechanical properties with different combinations. You can explore, for example, you can develop new binders, and then you can see that how they are performing or how they are influencing the mechanical properties. So these are technically, again, some of the advantages that the research community is currently exploring as well, by developing new binders or different materials like that. The process is therefore well suited for when the internal material structure needs to be a specific quality. This is again something important, that, for example, if the part needs to have different characters, so the inside of the material needs to be different character than the outside, then technically you can rely on different type of binders that can work in the part that is inside, and different kind of binder that can work with the outside one. So you can have different material structure internally present with a different quality. Then if I go to the next slide, this is the stuff taken from the textbook. So layers of the build material, often in the granular or the powder form, are held together using the adhesive binder. We know this thing already. The print head deposits the binding material in micro amounts. So these nozzles or orifices are very small, and the binder is coming in the form of micro dimensions. And the powder material is used in creating the majority of the overall object. A heated build chamber can help to speed up the printing process by increasing the viscosity of the material. So generally, the chamber where this process happens is temperature controlled technically, or it can be operated at higher temperature that facilitate the process uh, by increasing the viscosity of the powder material. Then students, one important part related to this process is the post-processing of the sample. So generally, when you print the part, it is a binded part together, and it is referred as green part, and later on it needs to be post-processed. So post-processing can be depowdering, for example, where you need to get the sample out of the powder because it is enclosed in the chamber. It has surrounded by powder itself. So you can use this. Basically, you can get the part out of. You need to get the part out of the surrounding powder particles. So this is one thing. Then you need to take it for sintering, for example. After sintering, maybe there's a need for polishing, maybe there's a need of machining, and like that one. So the overall process time is extended as it requires the binder to set. Yeah, this is also something that you need to wait for some time once the part is printed. In order to gain the proper hardness for the part, you need to give some time to the binder so that it can set itself. And the part is often allowed to cool in the machine to fully solidify and achieve the higher quality finish. Post-processing is often required to make the part stronger and give the binder material better mechanical and structural properties. Yes, so this is basically sometimes additional post-processings are needed basically so that the combination of binder and the material, powder-based material, can improve with the mechanical and the structural strength, for example. So this is the part. Then if I show you, this is like the image of these small orifice from which the binder is being dropped or being sprayed, you can say that, or this is the picture illustration. Because a print head can contain many ejection nozzles, this binder jet technology typically features an array of parallel nozzles for rapid patterning. Since the process can be economically scaled by simply increasing the number of printer nozzles, the process is considered scalable. And as I told you that it is a faster process, and you can even make it more faster by adding more nozzles to the print head. Such environments typically have a high deposition speed at the relatively low cost. So it is very good if you want to look into the scalability. Uh, so this is then the printed part is sometimes left in the powder bed after its completion in order for the binder to fully set and for the green part to gain strength. Post-processing involves removing the part from the powder bed. This is depowdering, then removing unbound powder via pressurized air. Then sometimes you spray air on it, high pressurized air, so that the powder particles can be removed, and infiltrating the part with an infiltrant to make it stronger and possibly to impart other mechanical properties. I will talk about this thing, what is infiltration or infiltrant. For metal and ceramic binder jetting technology process, a furnace processes a furnace operation to vaporize polymer constituent of the binder, followed by the powder sintering on the infiltration is done. So technically what happens, students, you are using a binder which is technically of a polymeric nature. So what happens when you leave it inside the sintering furnace? This binder sometime evaporates or sometime it drains out of the part itself, leaving only the powder particles together. And as a result of this thing, these powder particles, they sinter with each other. So this is what is being referred in this slide. And after that, what type of different materials that can be used? uh, Metals definitely can be used. Here it is mentioned stainless steel, but many other metals like inconel, titanium, they can also be used here. What polymers are used are ABS, PA, PC, and ceramic, for example, glass material can be used. So this is from the textbook now, that when Z Corporation first started in the mid-90s, their first material was starch-based, and they used a water-based binder similar to the standard household glue. I think that was just for the proof of concept initially when they developed the technology, and then they want to go ahead. So for example, at present, the commercially available powder from 3D system is plaster-based calcium sulfate amide hydrate, and the binder is water-based. Printed parts are fairly weak, so they are typically infiltrated with another material. Most of the time, students, the infiltration is a process where you leave another material, leave this part that is printed with another material, and another material, in a way that this new material will infiltrate, it will go inside and sit inside the material, and it will get kind of, increase the density. It can overcome the porosity or the porous nature of the material, and it will improve the overall performance. So this is something which is there. The book also mentions some names. So 3D system provides three infiltrant. The color bond infiltrant, which is acrylate based and is similar to super glue. Then the strength max infiltrate, which is two-part infiltrate and salt water cure and eco-friendly and hazard-free infiltrant. So there are different infiltrant chemicals technically that you can leave the object with once it's ready, and these materials will go inside and infiltrate. Infiltrate means that it will go and sit inside the pores of the structure, right? So in general, parts with any of the infiltrant are much stiffer. So this will add uh, strength in terms of stiffness to the material than the typical thermoplastics or wet polymerization, polymerized resins, but are less strong and have very low elongation at break. Okay, so this is the part. Then these texts are again taken from some of the books, because book was referring to these references at one point. So they are there for you. For example, Vauxhall Jet, this is a company, on the other hand, supplies a PMMA, which is methyl methacrylate powder, and uses a liquid binder that reacts at room temperature. They could recommend that the parts stay in the powder bed for several hours to ensure that the binder is completely cured. For investment casting pattern fabrication, they offer a wax-based binder for use with PMMA powder that is somewhat larger in particle size and the particle used for the part. So students, you can see this thing here, that different companies are providing different type of powder and binder pair as a material for different sort of applications. This is again where many researchers are currently working, and they are proposing these new binders as well as the new type of powders for certain application. Some as-built binder jet technology parts have as much as 60% porosity. They have high porosity because the binder, when evaporates, it kind of leaves the porosity inside, which may need to be filled in some circumstances if the polymer is used as a filler, which can be achieved using the dipping process. So what you do, sometimes you leave it inside another polymer. You keep the part there for longer duration, and the polymer material will again fill inside the actual material. This is referred as dipping process, where the base material is metal, steel, and the binder should be removed using the furnace. In some cases, a lower melting point material, bronze, can also be used to infiltrate the voids. X1 markets machines that use either metal or sand powder to form parts, or sand cast molds and cores, respectively. In the metal area, they market several stainless steel materials and several other materials that are infiltrated with bronze. Again, if you search, a lot of research is there where the steel-based components are infiltrated by using the bronze material, because in this case, you need to fill the material for the infiltration that is at the lower temperature. So generally low melting point metals are the better options here. Please read that one. They have many additional metals under development. So this is, I'm talking about the company called X1. They're working on different combinations of powder and material. For metal and ceramic, for example, here, ceramic materials, polymer binders are used to produce a green part. Uh, so green part, you know that it is the printed part when it is ready for the sintering process, or it is ready for the furnace. After fabrication, the green part is removed from the AM machine and then it is subjected to 2 to 3 furnace cycles. In the first cycle, low temperature is used for several hours to burn off the polymer binder. So generally temperature is allowed in the furnace or is applied on the furnace in the form of 2, 3 cycles. The first cycle is low temperature where it is only to get the binder polymer out or burn. In the second cycle, high temperature is used to center the material parts together. At this stage, the part is approximately 60% dense. And in the third cycle, the bronze ingot or other alloy, which is at the low melting point, then the powder alloy is placed in the furnace in contact with the part so that the bronze can fill inside the part pores, resulting in the part that are greater than 90% dense. So this is the overall process of binder jetting. You can see this thing. Some of the advantages are that you can print with different colors, use a range of materials, different families, metals, polymers, ceramic. The process is generally faster than others. The two material method allow large number of different combinations when it comes to binder and the powder itself. And you can explore different type of mechanical characteristics involved. Disadvantages related to that are that definitely uh, they are not suitable for structural applications because generally they do not have that much strength due to the use of binding material, and additional post processing are also important or also used in this case where they take a lot of time basically, right? So it's a significant, they consume a lot of time or significant amount of time when the post processing are used. Here, students, in this table, I'm showing you the different machine specifications, their company name, their build size, what is the type of resolution, layer thickness, what is the total number of nozzles, for example, what type of material it can work with. For example, you can explore the other ones at your own, but for example, I talk about the first one from the 3D systems. For example, this is ProJet CJP 260 plus, where the deposition rate uh, is 0.87 liter per hour. The build size is provided as you can see, resolution is 300 by 450, layer thickness is up to 0.1, and the number of total nozzles are 604. Calcium sulfate, hemihydrate, plaster of Paris, technically this is the material that is used. And you can look into the different other options for metals and at the same time plastics and for sand as well. Major applications of the materials which are coming out of this process, definitely, as you have seen, that they can be used or for the 3D printing of mold that later on can be used for the casting process. So casting patterns, cores, molds, these can be created from this process. It has ability to print aerospace parts, like if you're working with titanium Inconel, for example, it can rapidly create prototypes, full color decorative objects, which means that you can change the color in the printout. So it can do all of these things. And then it can also be used in the jewelry related applications as well. I'll show you some of the examples coming from the different papers, research papers. So you can see that this is from the X1 company. The first one is the filter. So this filter is there. If you talk about the second one, this is the casting. Uh, this was created for the sand casting application. So this is a mold. Then you have these automotive parts, automobile parts, which are represented in the figure C. D is technically heavy equipment and machinery parts. So these are some of the examples, some more examples from another research paper, for example. So the first one is the mold that was manufactured by binder jet and used to cast the part shown. B is the parabolic antenna printed in the stainless steel, and it is infiltrated with copper. Then another application is a fine featured part printed and centered to the fully dense to full density shows fine feature capabilities. This is a very complex form. D is the starch-based part with color printing, illustrations, and ability to spatially vary material properties. Then the last one is the slurry, which is coming from the binder jet made alumina tooth wheels. So these are, students, some of the examples of the different components and the different how they are relevant with the different industries. That's kind of sum up the basic introduction of the binder jetting process. So I'm a bit finishing a bit early today again, because this is mostly I'm recording myself and there is not much interaction with you guys. So definitely I'm finishing early, but if it is in a class, I'm sure it will take more time. Anyway, you go over the material, and in case if you need any clarification, any question from my side, please feel free to contact me. Thank you for your time.